Hey, welcome back. We'll continue where we left off previously, and in this video we will set up the logic for the countdown timer to set the text on that widget. Remember that this ES variable is now checked for this text widget, so we have a reference to that text widget in the graph. I will switch over to the graph. Here we have the tick event, which gives us access to the delta time. Remember, delta time is the amount of time in seconds that has elapsed since the last frame. Of course, this is a small amount since you could have 60 frames per second, for example. So in this video, we want to create a variable that will hold the countdown delay, so the amount of seconds, and then subtract the delta time from that each tick. With this, we can start at 5 seconds, for example, and then each tick we will subtract the delta time from that remaining time until we have 0 in the variable. And in this way, we can create a countdown timer and keep track of the amount of time left before we begin playing the game. To begin, let's create a variable to keep track of the timer remaining. This will be a float, so I will change that from boolean to float. Later we can declare this variable in C++, but we can use this temporarily to set up the basic logic. You won't always need the C++ class anyway. Sometimes you set up your widget in blueprints only, but in an upcoming lecture I will show you how to set up the C++ backend, and then you can expose some functions if you want. That is, if you want to do more complicated stuff going forward for your own projects. Now we can drag that in. The variable name is a bit long in this case, I just want to make it clear what this is for. But you can choose a shorter name such as game start delay or countdown time or something like that. Every frame we want to set the time remaining to the time remaining minus the delta time. So we have the subtract operator that we can use for this. Plug what this returns into the set node. Actually, let's go back and initialize the time remaining variable to 5. Let's navigate to our game mode, and let's change the game start delay to match the time remaining variable. We will set that to 5. These two variables are managed by two different objects. The game start delay is managed by the game mode, which of course we have declared in C++, but then we have just set up that blueprint variable. So of course those are two different variables that are managed by different objects. And later we will see how we can link those so that we can get the game start delay from the game mode, and then set the local variable in the widget to the same value that we have in the game mode. But for now we just want to get that basic functionality working. Back in the Apple Picker widget, when we have 4 or more seconds left, we want to display get ready. We want that to display for 1 or 2 seconds right before the countdown happens, which is why I set the time remaining to 5 seconds. Following the get ready display, when time remaining is 3, 2 or 1 seconds, then we want to display those respective values. So 3, 2 and then 1, and then eventually when we reach 0 seconds, you may want to display something that informs the player that they can now play the game. So in other words, we want to set the text widget to those values, and then to those values 3 to 1, and then eventually play. For this we can use the switch on int node, drop one of those down. We can click this add pin to add more output execution pins. We want 5 of those, 1 for each remaining second until the game officially begins. We don't need the default pin for the setup that I'll use, so with the node selected I will uncheck this has default pin box. Each output on this node will execute when that matches the input value. For example, input 0 will execute when the integer case is 0. Output 3 will execute if that selection or case integer is 3, and so forth. So of course our time remaining will count down from 5 seconds all the way to 0 seconds. And currently we are using a float variable for our time remaining. How do we convert that to an integer? Because the switch on int requires an integer, right? For the case. Well, we have a useful ceiling node called ceil. I'll drop that down. Notice that this node returns an integer. The operation will round your float argument up towards a positive integer. For example, 4.5 will become 5, 1.6 will become 2, and so forth. This is useful since let's say we have 2.5 seconds before the game starts. Then we can display 3 seconds in the countdown text. Only when the time remaining is less than 2 seconds do we set the countdown timer text to 2 seconds, and so forth until we have 1 second left. And when we have 0 seconds left, we will display the text play, for example. I will hook the return of this operation into the selection of the switch. That integer will be the case or selection for this node. Let's use a couple of print string nodes to see if this will work. When that integer is 5, so when the ceiling node returns an integer 5, then of course we want to print get ready, for example. Also if that is 4 seconds, but we'll set that on 5, and then of course that should also print on 4. because we will only change that on 3 seconds. But in any case, to test this, we can drag off the execution wire from the 5 output on the switch on int. So we drag off here and drop down a print string node, change that text to get ready. We can duplicate that. From 0 we will print play, so from 0 we can drag out that execution wire and change the text to play. Compile and save, and if we playtest now, get ready prints to the screen and eventually play will print to the screen. Notice that we get multiple printouts because of how the ceil operator works. Remember that will return each number from 5 to 0 multiple times, since it will round the float argument up to a positive integer each frame when we subtract the delta time from the time remaining. Let's delete those print string nodes and actually set the text. Alright, let's look at how we can actually set the text on that text widget. We can drag in and get the text widget, drag off from that and type set text. We have this operation here, set text, text between parentheses. This is what we will use to modify the widget text or set the text. So I will drop that down, hook that up from 0, so that execution wire from 0. When we reach 0 seconds, then we want to set the widget text to play. I will duplicate that, and at around 5 seconds, we want to set the widget text to get ready, for example. I will hook that up and then compile and save. If we play now, notice that the countdown timer text changes from get ready to play. At the moment that widget remains and keeps displaying play, we want to remove that after a second or two since that can be distracting. On 0 seconds I will begin by printing play, then let's print a string to the screen for debugging purposes, something obvious and annoying such as play in all caps. If we play now, once the widget text has been modified to play, notice that those play strings get spammed on the screen like this, and those will stop printing eventually. That is once the time remaining variable is below a certain value. We don't have a case for -1, right? So it stops below 0 eventually. The reason why I demonstrate this is that we can choose to only execute this logic once. I will drop down and hook up the do once node like this. The output execution wire from this node will fire only once. That is the first time program execution reaches this node, unless you reset that. With this logic we are specifying that we only want to execute the following code once. We want to set the text widget text to play, and then we want to print play to the screen. Alright, let's test that to see what we get. Notice when we play that our debug string gets printed only once. I will delete that print string node. Then from the set text, after about 2 seconds, we want to remove that widget text that keeps sitting on the screen during gameplay. So change the duration to 2 seconds here. But then what do we do next? Well, we have a couple of options which I'll demonstrate. One option is to simply set the text to an empty string. I will duplicate those nodes and hook up that set text following the delay. Then simply set the in text to an empty string, compile and save. And if we play now, following the countdown, the widget is modified to play. That is on 0 seconds. Then following the delay, it is modified again to an empty string. I will remove the setText operation. We can also remove the widget using the remove from parent function, which can be found under the widget category. Drop that down. Now following the delay, we will remove the widget from its parent. Before I play, I want to set the text on seconds 3, 2 and 1. So let's duplicate those nodes, hook up the execution pins from the relevant outputs, that is of the switch on int node, and then set the in text on those to the appropriate text. Compile and save. If we play now, our countdown timer should be complete. We should get our get ready text, followed by our countdown timer 3, 2, 1, and then play. Then play should disappear after a brief period, as we can see here. Let's set the game start delay to 5 in the game mode. Open up Visual Studio and navigate to our game mode header file. In the protector section, we have this game start delay variable. Let's modify that and initialize that to 5, since we require about 5 seconds for our current widget setup. Next, how can we assign this game start delay to our time remaining variable, which is local to our widget blueprint? Back in our widget graph, we want to set this local time remaining variable to the game start delay from our game mode. That is so that we have one place where we can set those values and initialize the game start delay, and then those variables are linked essentially. Now, since we only want to do this once, I will use a different event called onInitialized. We can get the game mode, which will return the current game mode base. From here, we want to cast to our Apple Picker game mode base or to the Blueprint derived class. Remember that when we drag off from that blue output, this is like using the access operators such as the dot or the arrow operators in C++. What exactly do we want to access here? Well, the game start delay, right? Now remember that that variable is protected in the C++ class, so we will have to define a getter function for that in C++. Back in Visual Studio, in your game mode header, in the public section, let's declare a function that will return a float. I will name this function getGameStartDelay, decorate that with the uFunction macro, and specify this to be Blueprint callable. Otherwise, you will not get access to this in Blueprint. That often leads to confusion, so make sure you remember to provide the required specifiers. Quick actions and refactorings, and create the definition. In the definition, this currently returns 0, but we want to return the game start delay, so let's modify that. So that will now return our game start delay variable. I actually have some squigglies here. I will fix that uFunction macro, I misspelled that. Save those changes and then rebuild. We should now have access to that function, getGameStartDelay. Notice that when we drop that down, that is when we drag off from the blue output as opposed to the execution wire, that it will hook up the execution wire as well. This can save you some time over the years, of course, if you have to do the same operations over and over again. So small things like this can save you some time. Our getGameDelay has this return value output. Let's hook that into the input in the time remaining setter. And that is it for this logic. Our local time remaining variable is now set to whatever we set the game start delay to in our game mode. Always keep these sorts of things in mind, otherwise you may have to change the initialization values in multiple places. I have demonstrated how we can do this sort of thing in C++ by getting the game mode and invoking functions on that, casting and so forth. And so this is how we can do this in Blueprints. To test this, let's go to our game mode blueprint and let's change the game start delay to something like 10 seconds. You could also use a print string to print out the values of the time remaining. I'll just do that for fun here. Print out the integer that this ceil operator returns. If we play now, we can see that the printout start at 10, and those will sync up with our widget counter on text. Now you can decide if you want to keep this print string in here, maybe just log those values out to the console if you want, but I'll actually remove that. Make sure the rest is still wired up correctly. Back in the game mode, we can now revert the game start delay back to the default value, which is set to 5 in C++. Compile and save those changes, play one more time just to test, and that should work fine. And so that was a look at how we can get the game start delay from our game mode. As an exercise, you can set this up in C++ if you want, but I leave it like this for this project. To wrap up this video, our getGameStartDelay does not modify the state of the calling object, so let's qualify that function and make that const. Save those changes. Congratulations if you defined the function as const in the first place. And that is going to wrap things up for this lecture. Our counter on timer now works, and in upcoming lectures we will set up a C++ user widget class and expose some functions. And at the end of the game, of course, we want to display to the player whether or not they have won or lost the game. So we will set up the logic for that.